So let's go ahead and take a look at number 6. And I might need to go ahead and add an extra page in here. So let me do this so I can have like a little scratch page. I know this is a little bit small on that side, but we'll get over there. So on number 6, we've got, I believe, 3x cubed plus 10x squared minus 8x. And if we want to, we can go ahead and do the degree and the leading coefficient stuff first. We can figure all that out. So I can see it's a degree 3. I can see the leading coefficient is positive 3. So a third degree positive leading coefficient is going to go, I think this is the right side. This is going to, oops. It's going to go up on the right and down on the left. I might just take this off of here. That might be too hard for my old eyes. Okay. Now it's like super big writing. Okay. Right? So we've got that. Y-intercept. P of 0, 3 times 0 cubed plus 10 times 0 squared minus 8 times 0. All of that comes out to a big old 0. It's the easiest way for me to get us a problem that has more factors, a bigger degree, is to throw an extra x. So x equals 0 makes that y-intercept turn into the origin. Okay. Factoring. I look at this. I see every term has an x. I'm always on the lookout for number 1 at GCF. Number 2, if it's not a degree 2, I know I'm probably going to have to do something to, because our goal ultimately is to get to some kind of degree 2 quadratic to work with. So factoring out an x gets me there. It gets me a very nice quadratic trinomial. We're all good. But my leading coefficient is not 1. Okay. There. Let's go over here. 3x squared plus 10x minus 8. I need factors that add up to 10, but the problem is it's not factors of negative 8. The thing that's a little tricky when your leading coefficient is not 1 is you've got to think about taking the combination of the leading coefficient and the constant. So it's factors of negative 3 times negative 8, or factors of negative 24. That add up to 10. So the 10 works the same way as when there's a 1 in the front. But the problem is, and a lot of times you'll figure that out real quick because you start going, well, factors of 8 that add up to 10, I can't do that. Right. That's because it's not because this doesn't factor, it's because it's not really factors of 8. We're doing number 6 on the notes. It's not factors of 8 that we're looking for, it's factors of negative 24. Okay. 2 factors. 12 and negative 2 are our magic numbers. When I do this, I always put, if there's a negative factor, I put that one first. What I'm going to do is use these 2 numbers to rewrite the middle. So I'm going to rewrite the middle term as negative 2x plus 12x. This front guy is going to come down. So the 3x squared is still there. The 8 is still there. think I said this a couple times in class last time. This is not the only strategy for factoring a trinomial when there's not a 1 in the front, but it's a pretty good one. It's got nice steps that you can follow. And it doesn't require you to kind of do things that are weird. You do things you know. You do a little multiplying to figure out where you're going to look for your factors. So 3 times -8 factors of -24. You pull the factors that add up to add up to positive 10. You rewrite the middle and then group to do GCF work. Your first two are always going to have at least a GCF of an x, maybe a constant. In this case, it's just an x. That's usually the easier one to do. But watch how I'm going to think about the back one. I'm going to go like this. I'm going to say, okay, wait, I know this has to happen. I got 3x minus 2 up front. I need to have 3x minus 2 in the back. And so I look and see, can I do that? Well, if I put a positive 4, a 4 times the 3x will get me the 12x, and a 4, so the 4 times the 3x will give me the 12x, and the 4 times the -2 will give me a -8. If I can't make 2 sets of parentheses that match, I'm not doing it right. If you pick the right middle numbers, it'll work. If you pick the right middle numbers, but you flip-flop them in order, it'll still work. It's just not, sometimes it's easier to put the negative first. That's just what I have found, so that's my suggestion. It's not a you have to do it. Final answer for factors. You take the 3x minus 2 that they have in common and the leftover stuff. So basically, if you took 3x minus 2 out of both of these, you'd be left with x plus 4. Now, all of that is side work, for sure. Right? Chloe, go ahead.
So, like, on the other ones that we were just doing, you know how we just, like, put it in, like the, I don't know, like, the last time we did
We just did, like, 20, yeah, we did 25 and 10, so it's 2 5s, and we just threw the 5s in there, yeah.
and you said throw in there, how do you know, like, that you have to plug it into the whole equation and kind of, like...
Because you don't have a 1 in the front. It's all because of this guy. The different, if that's a 1, then everything works more easily. If it's not a 1, that's when things get more complicated.
Okay, so a 1 or a -1?
A 1 or -1. And if it's a -1, I would just factor the negative out and make it a 1. So yeah, a -1 is easy to fix to make just a 1. But any other number as your leading coefficient or any other number as your coefficient on your x squared term means trouble. Those are good questions. Diego.
Can you only use this method when it's a descending exponential value? Like let's say x, like 3x, and then it's 3x fourth, or like 3x to the power of 4, and then it goes minus 2x to the power of 2. Can we still do this? Because then wouldn't the, when you would try to find the greatest common factor, it would be like 4 on one side and then 2 on the other.
Yeah, so if your question is, are there lots of times where this doesn't work? The answer is, oh yeah. Like everything kind of has to be set up perfectly to work. But here's the nice part. I'm not just randomly throwing problems at you saying, okay, well, I don't know if it's going to work, but let's try it. If I give you things, the things I'm going to give you to do on your test, they're going to work. So if I give you one that has a GCF, and when you fool the GCF, you've got an X, it's going to work this way because I've created it to work this way. Does that make sense? There are, and I agree, and that's why this is a hard topic to teach, because it's like, we're teaching one little way to solve problems for one little specific type of problems, and there's all these other types that we can't do this way that take other things to do that we don't know yet. So we're just like, okay, here's all the polynomials in the world, and here's this one. We're going to talk about how to solve this one little really nice pretty group of count. Okay. You're okay with the x here and you're okay. So what I did was, when I looked at this final answer, after I did my groupings, the groupings had a 3x minus 2 in common. So I took the common factor, and then this factor, I put the GCFs together. So I put the x and the plus 4 into that. So if it had been, like, let's just pretend I did a bunch of work, and we had 3x and x minus 5, and then plus 2 and x minus 5, my answer would be, and I'm sorry, I'm going to be inconsistent. I got to be consistent. I would do x minus 5. See it? Okay. Okay. Other questions, issues, concerns? Now, here's kind of the crappy part. We did all that work and we had to do all that thinking. Like I said, that was side work. That was us figuring out that. We did all that over to the side to kind of figure that out. You're not going to have to do that much work on every single problem. I'm not going to give you like 12 of these to do on your test. I don't have to see if you can do 12 of them to know if you can do it, right? If I give you 1 or 2, then I can pretty much get an idea of whether you can do this or not. So don't get upset and think like, oh, we're going to have like a million of these, I'm never going to get it. No. But you are going to have to do one like this. You're going to have to factor a quadratic when it's not a 1 in front. Zeros. 0, 2/3, and -4. Because I took each factor and set it equal to 0. 2, 3, -4. So if that's 1, we'll mark 2/3 right there. And then up from that one and down from that one. So this is really kind of squishy right there. Nope. Don't have to do. Lazy. Okay. That's going to be the hardest thing. The other 2 things we're going to do under the which I'm calling weird stuff, actually both of them are easier, I think. And that's me judging it for students. You're like, oh, of course you think it's easier. It's easier than it's less steps. So let's get into, I know that you're probably not 100% like loving your world on this right now. We're going to have to practice this some more. That kind of factoring is going to take a little bit more practice. You'll have an opportunity to do some more with this. When we do our inequalities, some of them we'll have to factor like this. So we'll practice this some more. If you feel okay with everything that happened after we got the factors, you're great. If you're still a little sketchy on how we got the factors, then yeah, then that might be what you need to work on. But we are going to work on that together. Okay. So, weird stuff. Here's a weird stuff problem. I actually only have one of the 2 weird things in these notes. The other one I didn't know we were going to do, so we're going to have to sort of add on a little side page, but that's okay. For this weird stuff, I'm calling this one like a quadratic. It's not quadratic. It's a degree 4, but it's a 4 and a 2 and a constant. When we have a quadratic trinomial to factor, we have an x squared and an x and a constant, right? We have some version of that. When a is 1, everybody's happy. It's super easy, a lot easier to factor than when a is not 1. Something that's that works like a quadratic is where this is some even number and this is half of that even number. So if I have something like 5x to the 4th plus 2x squared plus 1, that's sort of like a quadratic. If I have something like 8x to the 6th and 5x cubed plus 10, that's like a quadratic. It doesn't have an official name, at least not that I know of. Some people call it like a quadratic form. I always just call it, hey, it's like a quadratic. It's sort of like a quadratic. It's not, but it works like it. It's got an even exponent. It's 3 terms, an even exponent on the leading term, half that exponent in the middle, and a constant on the end. Okay? So you're going to recognize this because it's going to look like that. You're going to say, oh, I see. It's got the characteristics. It's got 3 pieces. It doesn't have a GCF. It's got a first term that's an even power, a middle term that's half of that, and then a constant. Are we okay with the like a quadratic look? Right, when we see one of these guys. All right, so we see him. And here's what I'm going to do. And I'm purposely making them like a little bit more friendly for us. This is like a quadratic, and it's got a 1 in front, which makes me happy. So I'm going to factor this kind of the same way I factor happy, fun quadratics. Happy, fun quadratics, when it's a 1 there and I have an x squared, I go xx. Well, this guy, I'm going to go x squared, x squared. Does that make sense? I mean, are we okay with that? X squared would pop xx. It's x to the 4th, so I'm going to go x squared, x squared. Now, factors of 8. Factors of 8 that add up to -6. See, I'm going just like I'm in full-on quadratic mode, fun quadratic. Factors of 8 that add up to -6, -4, and -2. And those are my factors. Look at that for a minute. See if you can sort of wrap your head around what I did. It was an x to the, when I looked at it, I went, I can't do a GCF. So I'm kind of sort of going down my list of like, how am I going to do this problem? It's not a problem where I'm doing a GCF. It's not a regular quadratic. It's a 4-2 constant. It's like a quadratic. So I'm going to hit it with the same kind of factoring thoughts that I do with a quadratic. X squared minus 4, x squared minus 2, minus 4 minus 2 will give me a -6 x squared. Minus 4 and the -2 will give me the -6 x squared, and the -4 minus 2 gives you the +8. How do you think I'm going to get my roots from this? How am I going to get... How am I going to get my roots? They're like, what is she like? What's going on? Ah, oh, now you're all pink. I'm sorry. Jack, how are we going to get some roots from these? You're not sure. All right, so what did we do last time when we had factors? How do we get roots from factors? What did we do with each factor? Set it equal to 0. Okay, so I'm going to do that here. You're like, I don't want to do that. Well, it's okay, but we're going to do it anyway. I'm going to take my x squared minus 4 factor, and I'm going to set it equal to 0, and I'm going to take my x squared minus 2 factor and set it equal to 0. Factors set equal to 0 give us roots. Factors set equal to 0 give us roots. All right, we're going to hit this with our best Algebra 1 skills. X squared minus 4 equals 0. How about I do this? X squared equals 4. Give me some solutions. If x squared is 4, what would x be? It could be 2 or negative 2. This is a degree 2 factor, so it has 2 roots. It's not a double root because it's not the same root, but it's 2 roots. All right, this one's not going to be as fun. It's going to make us sad. X squared equals 2. So what would x be? What's the algebra? Because this one we just kind of think about. What's the algebra here? How do I get from x squared to just x? Yeah. Take the root of both sides, right? So the square root of x squared, the square root of 2. All right, so here's a little revelation for you. When I take the square root of x squared, I get the absolute value of x. I know you don't want to hear that, and I know you're thinking that you're now thinking, nuh-uh, square root of x squared is just x. No, it's not. No, it's not. What happens is you take the square root of both sides. The square root of x squared is the absolute value of x. And if the absolute value of x gives me a root 2, because that's what happens when I took the square root of that side, the absolute value of x is root 2, then x has to be either a positive or a negative root 2. Now, I will give you 100%. Actually, you know what? This is probably more what you did. Depending on who you spent time with in Algebra 1 and Algebra 2, you probably kind of skipped that in-between step. That's okay. It's not great. Later on in calculus, we'll talk about why it's not great to think about it that way, but it gets you there. The square root of x squared isn't just x. The reason you end up with the plus or minus is not just magically because of the square root. It's because of when you take the square root of both sides, you take the square root of x squared, it's really the absolute value x. So that's how you get to the plus minus. Okay. And I'm being honest with you, because when I taught Algebra 1, I didn't teach that. I kind of skipped that, because you really just kind of want to get here when you're solving a quadratic, and so you don't need to talk about that a lot. But unfortunately, I'm a calculus teacher now, so I know later on you're going to need that. So I'm going to throw that in for you. Go ahead, Diego.
Are you gonna get points taken off on a test if you don't?
Nope, as long as you end up here. That's my point. Yeah. So you're like la la la, I'm not listening. X equals plus or minus root 2. That's fine. Okay. When I have you in calculus, I'll make you think about it that way, because there'll be problems where we have to. Okay. So we did all that work and we got 4 roots. Well, that makes sense because it's a degree 4. Both sides are going to go up. My y-intercept is 0, 8. My roots are 2 and negative 2, and root 2 and negative root 2. Now, if you're like, well, how am I supposed to graph root 2? Well, we're going to approximate it, right? Root 4 is 2. Root 4 is 2. Root 1 is 1. So root 2, somewhere between 1 and 2. It happens to be one of the ones I have memorized, 1.4, 1.4. You may or may not have that memorized. It's a good one to know, though, that root 2 is about 1.414. But for our graph purposes, as long as we're getting that it's between 1 and 2, so 1 and 2 and negative 1 and negative 2, we're going to have roots at negative 2 and 2, and then kind of in between here for the square roots of 2, up at 8, up off of there. So yeah, real kind of little, and nice symmetry probably. These 4th degree polynomials typically have a nice symmetry. I'm sorry, I know for if you're like, there's a little bit of a visual overload. A lot of stuff right now. Okay. So, when we're doing like a quadratic, that means we're going to have a little extra fun finding the roots. Because we'll have 2x, well, if we're going to pretty much stick to x to the 4ths in this style. And so our like a quadratics, we will be working with an x squared. Yes. Say that again. Oh, leading coefficient is 1. Yeah, I wrote a bunch of nonsense over here. Yeah, so the leading coefficient here is just a positive 1. It's just the coefficient of the x to the 4th. Okay. Sorry. Okay. Now, I know I would really like you to practice that, but I do want to show you one more thing. Now, I am recording today's notes, so that's a good thing. So later on, so over this weekend, before class on Tuesday, to practice this, you can kind of go back and look at this. You're going to get, well, the homework assignment you already have has problem number 7. No, I lied. That's the one we just did in our notes. Maybe number 6. You've got one of these. Yeah, problem number 6 you can is a good practice for this. Okay? All right. I'm going to show you one more thing. I know you don't want to see it. I know you're like, leave me alone, but I got to show you one more thing. So let's do this. I'm hoping that you'll remember this a little bit from Algebra 2. I forget what the Algebra 2 teacher said that we were telling them at lunch. We're like, they don't know this. And they're like, yes, they do. Tell them it's the box division thing. I don't know. They didn't call it synthetic division. Did you ever hear that? Synthetic? Oh, okay. They lied. Somebody did. Okay. Some teachers called it synthetic division. Okay, so we're going to use synthetic division to help us get to factors. We're going to start with a root. So our other weird stuff, like a quadratic, is one weird scenario. Okay, we're going to go totally rogue here on a, you might need a new sheet of paper. We're going to do one more kind of problem. And that's going to be, what do we do when we start with a root? Start with a root problem. Okay. All right. All right. So how do we know when we run into this problem? Well, here's the thing. Number one, we look at it and we're like, well, there's no GCF, but it's not a quadratic, but it's not even like a quadratic because it's got 4 terms. And here's the other big revelation. I'm going to tell you one of my roots. I'm giving you an x-intercept. Here's the polynomial. Here's one of the x-intercepts. How many x-intercepts, what's the maximum number of x-intercepts this polynomial has? 3. All right, so I've given you one of them. We're going to have to look for the other 2. So we're going to use division, and we're going to divide by that given root. We don't have to use synthetic division. We can use regular polynomial division. There's 2 different ways we can do this, but I'm going to show it today using what's called synthetic division, which is just a division trick. Okay. So this is how I write synthetic division. There's my -5 that I'm going to divide by. And I'm going to write these numbers down. Where did those numbers come from? Do you remember? Where did I get those? Cal? Yeah, they're the coefficients of these guys. So this is the 1x cubed, and the 3 from the x squared, and the -13 from the x, and the constant. Okay. All right. Step 1. Bring it down. Okay. After you bring down, you multiply. So the one that I brought down times the -5 root makes a -5. And I'm going to write that -5 under the 3. And then I add. 3 and -5 is -2. And then I do that, multiply, add over and over again until I can't go any further. And if it's really a root, at the very end, I'll know because I'll come up against 0. Right? So 1 brings down to start things off. 1 times -5 is -5. Add to 3 is -2. -2 times -5 is +10. Add -3. -3 times -5, +15. Add 0. Yay. That should happen. If you don't get that 0, that means that wasn't really a root, or you messed up. If it's a question on a test, that means you messed up because I'm giving you a root. You can do lots of different things with synthetic division. You may have learned synthetic division to check roots. It's quick. It's like not real division. That's why it's called synthetic. I guess that's why they call it synthetic division. It's like fake division. It doesn't look like our real long division. Now, how did that help us? Do you remember what happens with these guys? Why is this, what's that all about? And you may not remember because you may have not even done this part with it. You may have just done the synthetic division and not known like what other things you could do with it. All right. Here's how it helps. These numbers are new coefficients of a new polynomial that is one degree less than you started with. So 1, -2, -3 becomes 1x squared minus 2x minus 3. Oftentimes we use synthetic division to get ourselves from a high degree down to a quadratic. We can use synthetic division to divide if you know you have a root, and there are mathematical things you can do to find out potential roots, and then you can check and you can kind of guess and check to find one that works. Once we find a root, or once I give you a root, you do the synthetic division, you get a new polynomial that's 1 degree less. And if we had started with a 3, we're at a 2, a degree 2 polynomial, otherwise known as a quadratic, that hopefully factors. All right, so if we have x squared minus 2x minus 3, I can finish the factors. X minus 3x plus 1. So what was it? So my final set of factors, it's a little tricky because I've got this. Okay, so they gave me the root of -5. Let's go here. Let me throw here. I know. Whoop, whoop. Okay. You were given that -5. Okay, that's part of the present at the beginning of the problem. You're like, oh, okay, here's the polynomial and here's a root to start with. That's one of the things we're going to do to make this a little easier. If we were working at this at a little bit more of even a higher difficulty level, we would have to like go through some processes to sort of try to find ourselves a root. I'm going to give you a root. We're going to divide by that root. We're going to get a new polynomial that should be able to factor. So when I get to the end of the problem, I have my roots of -5 and 3 and -1, because the factors, I got the x minus 3 and the x plus 1 factors for when I factored the quadratic from the x squared minus 2x minus 3, and then an x plus 5 factor I get from knowing x equals -5 is a root. Okay. Deep breaths. I have no expectation that you are mastering this today. I understand you're not.
It's going to be on the test.
Yeah, it's going to be on the test though, right? But the test is not till Monday the 20th. And we've got next week to work on this more. Yes, ma'am.
You're gonna give the first grade.
Yes. Yes. So everything I'm telling you about this style of problem, I will give you the root. You'll have to divide by the root, and then you'll have to factor to find the other roots. Now, you can decide if this is harder than when your leading coefficient isn't 1, or if like a quadratic is harder. I don't know. They're all a little confusing for different reasons. Precalc's not easy. It's not. Right? The stuff's not easy. And I've taken away your calculator too. So like that's the other thing. You're like, you're doing all this and you're not using your calculator. Just hang up before you like pack it up, right? Question, Taylor. I will give you the root. Yes, I will give you the root. So we've got things that need to get practiced. If you just watch me do it, and then you sit down to do it on a test, that's real hard to like reproduce. You've got to practice this, which is why I have this for you. Okay. Now, you'll see when you get this that this first part is sort of the same kind of questions we had on a quiz. This is a review from what was on the quiz. Then you've got a factored polynomial. You've got one where I've given you the root. You've got it's a little tricky. It's going to be a GCF, and then it's going to be like a quadratic. And then this is going to be a GCF and a little tougher factoring. So you've got, really on the back of this page, 3 different problems to do to practice all of the different things that we've talked about today. You don't have to have this whole thing done for Tuesday. Actually, there's a whole part of this that you can't do yet. You can't do 15 through 18. But what I want everybody to do for Tuesday is 1 through 11. Okay? So I'm going to pass this out. And yeah, when I was copying it, the copier was on like we're going to use fake staples. And so it's kind of got that weird eco-friendly stapling. Stapling without staples. Now, if right now you're thinking, oh my God, I'm going to fail, then maybe you are thinking about coming in after school on Monday to work on these problems and so you can get help. So sort of plan for that, maybe. I am available after school on Monday. Homework for today on the unit review. One through 8. All right. Now, what we did, I'm going to go ahead and stop that right now. I just recorded